Hello everybody. Welcome to my channel Reshma Physics. In this video, let us discuss about some problems related to the quantum mechanics. This is my old notes. So I am explaining the problems of this particular quantum mechanics which I prepared. Now the duration of radar pulse is 10 to the power of minus 6 seconds. The uncertainty in its energy would be uncertainty formula. So here he gave duration means time. Energy means delta E. Uncertainty in energy delta E. Uncertainty in time delta T. So delta E delta T is greater than or equal to h by 2 pi. Right? So h by 2 pi delta T you send to this side. Delta E equal to h by 2 pi delta T. H Planck's constant 6.62 into 10 to the power of minus 34 divided by 2 into pi 22 by 7 into delta T he gave us 10 to the power of minus 6 seconds. Now simplifying, we get the value of delta E as 1.05 into 10 to the power of minus 28 J, which is nothing but the uncertainty produced in the energy at the radar pulse of time 10 to the power of minus 6 seconds. Now next, let the uncertainty relation be delta x delta p approximately equal to 7. If the size of nucleus is 10 to the power of minus 15 meter, the uncertainty in momentum of proton remaining within the nucleus is of the order. So he gave delta x delta p approximately equal to 7. The size of nucleus he said 10 to the power of minus 15 meter. The uncertainty in momentum of a photon within the nucleus is of radius he is asking. The uncertainty in momentum means delta x delta p equal to h or delta p. He is asking to find delta p itself only, h by delta x. H Planck's constant 6.62 into 10 to the power of minus 34. Delta x is 10 to the power of minus 15 meters. So if we solve, we get 6.62 into 10 to the power of minus 19 kg meter per second. Right? Now next, the uncertainty in the location of particle is equal to de Broglie wavelength. Uncertainty in location of particle, that is delta x, is equal to de Broglie wavelength lambda, he said h by mv. Then uncertainty in velocity, he is asked. Delta x delta p equal to h, delta p equal to h by delta x. Now that is h by, what is delta x he gave? H by mv, no? So we substitute h by mv. So now delta p becomes h strikes of mv. So p equal to mv, okay? Delta p equal to m delta v, delta p equal to m delta v. So m here, delta p means mv. So this m strikes off. So del uncertainty in velocity is nothing but v. Okay. So please don't concentrate on the question numbers. So which I practiced for the in quantum mechanics. I'm saying that particular problems. Now next, which of the following wave functions can be solutions of Schrodinger equation for all values of x? He is asking the solution of Schrodinger equation. Psi equal to a secant, psi equal to a tan x. Let us take these two. Let us assume these two as the solutions. Whether this will be the solution, let us see. Actually, these two are discontinuous and become infinite at particular values pi by 2, 2 pi by 2, 5 pi by 2. Alright. Now let us take another wave function. Psi equal to a e to the power of x square. This becomes infinite at x tends to infinity, plus or minus infinity. So, these two cannot be the solutions, but this can be the solutions because it is becoming infinite at x tends to plus or minus infinity. So psi equal to a e to the power of minus x square becomes the solution for Schrodinger equation. Now next, the wave function of a certain particle is psi a cos square x for minus pi by 2 to plus pi by 2. The value of a he is asking to find out, right? First, the condition integral psi star psi d tau equal to 1. Okay. Limits minus pi by 2 to plus pi by 2. Psi is a cos square x. Psi star psi no. Again a cos square x dx is equal to 1. Psi star a cos square x. Psi a cos square x dx equal to 1. A into a square I wrote outside. Integral minus pi to plus pi. Okay. Cos square theta means, what is cos square? Cos square theta? 1 plus cos 2 theta by 2. Right? So 1 plus cos 2x by 2. 1 plus cos 2x by 2 dx is equal to 0. 2 2s are 4. I am writing outside the integral. A square by 4. Integral minus pi by 2 to plus pi by 2. 1 plus cos 2x into 1 plus cos 2x dx is equal to 1. Right? Now, here multiply these two. What you will get? 1 into 1, 1 plus 1 into cos 2x, cos 2x, cos 2x into 1, cos 2x plus cos 2x, cos 2x, cos square 2x into dx is equal to 1. Again, a square by 4 integral minus pi by 2 to plus pi by 2, 1 plus these two adds 2 cos 2x plus cos square 2 theta. Cos square 2 theta is 1 plus cos 4 theta by 2. That we wrote here. Okay. So 1 plus cos 4x by 2 dx is equal to 1. Okay. Actually this formula only. Here we got 2 no. So it becomes 2 2s are 4 theta. That's it. Now next, a square by 4 integral minus pi by 2 to plus pi by 2. You see, I'm separating this. First I am multiplying with this and then with this. Now here a square by 4, 1 plus integral minus pi by 2 to plus pi by 2, 1 plus. Next here you see 1 by 2 we will get no. 1 by 2 dx plus again a square by 4 integral this 2 cos 2x plus cos 4x by 2 this one into dx is equal to 1. Now this term becomes 0. So what will remain? A square by 4. Here 1 plus 1 by 2, 3 by 2. Dx integration x minus pi by 2 plus pi by 2 equal to 1. Substitute the limits. A square by 4, 3 by 2. Okay. Pi by 2 plus pi by 2 is equal to 1. 2 pi by 2. 2 strikes off. So 3 a square by 8 equal to 1 into pi equal to 1. So from this we will get a square equal to 8 by 3 pi or a equal to under root 8 by 3 pi. Right? Just when you write the notes, pause the video and just write down the notes. Now next. The wave function in the ground state of hydrogen atom is given as what he gave wave function psi equal to a e to the power of minus r by a. Where r measures the, what is r I said in last video? Distance from the nucleus. And a is a constant. Then he is asking to find the value of this capital A. Okay. For that, the condition integral psi star psi t tau equal to 1. Integral in place of psi what he gave? A e to the power of minus r by a. Into psi also a e to the power of minus r by a d tau equal to 1. So integral a into a square e to the power of minus r by a into e to the power of minus r by a becomes e to the power of minus 2r by a d tau equal to 1. The standard value you have to remember the d tau r square dr sin theta d theta d pi. What is the value of d tau? R square dr sin theta d theta d pi. So now a square integral 0 to infinity, 0 to pi, 0 to 2 pi, e to the power of minus 2r by a. In place of d tau, we substituted r square dr sin theta d theta by t pi. So now here, but integral 0 to pi, 0 to 2 pi, sin theta d theta t pi value is 4 pi, standard value, remember. So now here integral, now let us write a square, okay, 0 to infinity, e to the power of minus 2r by a, r square dr, in this place 4 pi. We substituted and I wrote here, equal to 1. Now the integration value of 0 to infinity e to the power of minus ax x to the power of m minus 1 dx is factorization m by a to the power of m. Right? Now here you see what is there, r square. Okay? In e to the power of minus ax. Now this I am writing minus 2 by a into r. So in the place of a, minus 2 by a is there. Now m minus 1, no, r square is there. 3 minus 1 is nothing but 2, no. So 2 I wrote it as 3 minus 1 to get this form of m minus 1 dr. Now a square 4 pi 0 to infinity e to the power of minus 2 by a r 3 minus 1 dr equal to 1. Now here what he said, factorization 3 a square 4 pi. Formula is factorization, in place of m 3 we are having. In place of a 2 by a we are having whole cube equal to 1. Factorization of 3 is 2 into 1 only, no? So here you substitute 2 into 1 by 2 cube. Here a cube comes in numerator. So now 1 2 cancels. Here there will be 2 square, 4 cancels. Now what is remained? A square 4 pi. This all cancels. So a square equal to 1 by pi a cube, or a equal to 1 by under root pi a cube is the required answer. So the value of a is 1 by root pi a cube. Now next question. In the case of wave function, again he gave the wave function psi e to the power of I k r by r. The probability current density is asking to find. What is the formula for current density? In last videos we discussed the formulas h cut by m, I m, psi star del psi. Okay. H cut m I m psi star e to the power of I k r by r del psi. What is the operator del? I said dou by dou x only, no? So here dou by dou r we are taking with respect to r, no? So dou by dou r into psi. I wrote this total term as dou by dou r into psi. Okay. Now h cut by m, I m. Now here psi star e to the power of I k r by r dou by dou r psi e to the power of I k r by r. This is psi star, this is psi. So here I kept minus. So now e to the power of minus I k r by r. Now we are differentiating this. Okay. First u by v method we are using. U v dash minus u v dash by v square. So first what we wrote? This is u, this is v. V means r. U dash here I k e to the power of I k r minus again u, right as it is, e to the power of I k r, v dash r equal to 1 by r square. V square, no? V is r, no? R square. Okay, we used this method. Here this is v, this is u. V u star I k e to the power of I k r minus u v star, r differentiation 1 divided by v square. V is r, no? R square. Now next h cut by m I m. Now what is remained? You see here r strikes off. 1 by r square is there. I wrote here I k e to the power of minus I k r plus I k r e to the power of 0. E to the power of 0 1. So what remained? I k minus, here you see again this also same 1. So this is 1 by r cube. Here there is no R no. Now I multiplied first this. R strikes off. Now next, close this. Here already one R is there. Here R square is there. And this e to the power of 0, 1 by R cube. Right? How I did means h cut by m, im, e to the power of minus ikr by r into r ik e to the power of ikr minus again e to the power of minus ikr by r. Here what is there? E to the power of ikr by r square. So I got 1 by r cube. I'm taking 1 by r square common, ik minus 1 by r. So h cut by m. Now im, ik minus 1 by r value is k. By m, here already there, r square. Okay. Now v equal to h cut k by m. K propagation vector, v velocity, m mass of the particle. So jr becomes v by r square. Okay. In place of h cut k by m, I substituted v. So jr becomes v by r square. So the probability current density is v by r square. Right. Now next, the state of free particle is represented by a wave function psi x comma 0 equal to n e to the power of minus x square by 2a square plus I k naught x. The value of normal n is. So normalization condition formula, psi square dx is equal to 1. Integral minus infinity to plus infinity. Integral minus infinity to plus infinity, psi square. Here what he gave? This value no. N e to the power of minus x square by 2a square e to the power of I k naught x. I separated this. Actually, he gave n e to the power of minus x square by 2a square plus I k naught x no. I separated e to the power of into e to the power of. I wrote. Whole square dx is equal to 0. Now n square I wrote outside. Minus infinity to plus infinity. Now first you see e to the power of minus x square by 2a square into e to the power of minus k naught x. I'm writing the same thing, you see. E to the power of minus x square by 2a square e to the power of I k naught x dx is equal to 1. The normalization condition, we used psi star psi. Okay, psi star psi. Here minus I becomes, here plus I becomes minus I for psi star. Psi as usual we wrote. I used this only. Ditto. So for psi star, remember I becomes plus I becomes minus I. So now for psi as usual I wrote dx is equal to 1. Okay. N square I wrote outside. Now what we will get? N square integral minus infinity to plus infinity. Now this value is a root pi. Okay. So e to the power of minus x square by 2a square, right, into e to the power of minus x square by 2a square. So what we will get? E to the power of minus 2x square by 2a square. 2 strikes off. Okay. So what remained? E to the power of minus x square by a into e to the power of minus I plus I. So it will be 0. E to the power of 0, 1. So now that only I wrote here. N square integral minus infinity to plus infinity e to the power of minus x square by a square dx is equal to 1. N square, the value of this is a root pi. I substituted equal to 1. From that n we get 1 by a to the power of 1 by 2 pi to the power of 1 by 4. Right? Now next, the wave function in ground of hydrogen atom is psi 1 by pi a cube under root e to the power of minus Ra, the average R. Average as usual. Integral psi star R psi dz. Psi star minus Ra 1 by root phi a cube. Okay. If I is there only, plus I, minus I we will write. But here there is no I, no. So as it is I am writing. Minus R by A psi star into R. Again psi e to the power of minus R by A 1 by root phi a cube d tau or dz means R square dr sin theta d theta d pi. Okay. Now I substituted here. Integral 0 to infinity, 0 to pi, 0 to 2 pi, e to the power of minus 2Ra. Here, minus Ra, minus Ra, minus 2Ra into 1 by root pi a cube, root pi a cube, pi a cube. R into R square R cube, dr sin theta d theta d pi. But the value of this we know as 4 pi. So this we are substituting as 4 pi. I am writing 4 pi outside the integral and 1 by pi a cube also outside the integral. Integral 0 to infinity e to the power of minus 2r by a r cube dr is remained. So now the value of this is nothing but 3 by 8 a to the power of 4. Now if we simplify, pi cancels, a cube cancels. Now what is remained? Now 4 2s are 8. So 3 by 2 a is remained. So this is the average value of R. Now the next question. The expectation value of momentum of a particle whose wave function is psi of x e to the power of minus x square by 2a square plus ikx. Okay. Now let us solve this. So now how to solve this means now we gave same formula. We are using integral psi star. Okay. Psi star. Here he said the expectation value of momentum. No. Okay. So expectation value of momentum. What is that? Minus infinity to plus infinity. Psi star t psi dx. Minus infinity to plus infinity. Psi star momentum operator. In last videos we discussed minus I h cut dou by dou x, right? Psi dx. Okay. Now psi how much he gave? Psi of x e to the power of n e to the power of minus x square by 2a square plus ikx he gave. Minus infinity to plus infinity. Psi star. What I said, in place of plus x plus I, we will get minus I. So I am writing n e to the power of minus x square by 2a square. Right? Into e to the power of, instead of plus I, minus I. Psi star minus I kx into, next what is here? Minus I h cut dou by dou x. Psi again you write n e to the power of minus x square by 2a square into e to the power of ikx. Right? Now n into n, this is n square. Right? Now these two, e to the power of minus 2 x square by 2a square into e to the power of minus ikx plus ikx e to the power of 0, which is 1. So n square, here you are having minus I h cut dou by dou x. Don't forget to write that. So now this becomes 2 strikes of e to the power of minus x square by a square. Okay. Minus I h cut. Right. Okay. Now what we wrote? Minus x by 2a square e to the power of minus h cut e to the power of, again I wrote this. In UV method, I differentiated this, see. Right? Now see, n square plus infinity. This as it is I wrote. E to the power of minus x square by 2a square e to the power of minus I kx. Now this one, minus I h cut. Now dou by dou x, no this one. Right? N I wrote here, n into n is square. N square e to the power of minus x square by 2a square. Okay? E to the power of I kx. Now UV method. UV dash plus V U dash we will use. Right? UV method we are using. Now see. This e to the power of minus x square by 2a square e to the power of minus I kx minus I h cut into u e to the power of minus x square by 2a square. V e to the power of I kx. Okay? Into ik, differentiation, plus v e to the power of I kx u dash. So here what is there? E to the power of minus x square by 2a, no? Again differentiating x square, we will get minus 2x by 2a square. E to the power of minus x square by 2a square. Here I will do C n square. First term as it is I wrote. No changes. Right? Now this one, UV method. UV dash plus VU dash. First UV. Right? U as it is. Minus x square by 2a square. Now V dash. I kx is there, no? Ik, differentiation. E to the power of I kx. Plus V means e to the power of I kx. U dash. E to the power of minus x square by 2a square into, again x square we have to differentiate, no? So it will be minus 2x by 2a square. Okay? This only I wrote here. Okay? Now, n square. Here what I am doing, e to the power of minus x square by 2a square. E to the power of ix I took common. Here what remained? Ik. Minus here what remained? 2 strikes of x by a square dx. Right? Now, here you see, e to the power n square integral minus infinity to plus infinity e to the power of minus x square by 2a square. I h cut. Okay. Now, this e to the power of ikx, e to the power of minus ikx, e to the power of 0. That is 1. Now, what remained? Ik minus x by a square dx. Now, again n square integral minus infinity to plus infinity e to the power of minus x square by a square. Now, h cut k. Okay. Now, here plus we multiplied this with this and again this with this. I into I square minus 1 value. Here already one minus is there, no? Minus plus. So what I got? E to the power of minus x square by a square h cut k. Okay? Minus becomes plus. Integral minus infinity to plus infinity n square overall outside I got. I h cut x by a square dx. Now if we simplify this value will be 0. So h cut k and this value in the before problem we wrote, no, a root pi by a root pi. So momentum value you see. And next we want how we got this a root pi, n value. So actually n equal to 1 by a to the power of 1 by 2, pi to the power of 1 by 4. We get it, 1 by a root pi. That only we wrote in place of n, 1 by a root pi we wrote. Right? So now a root pi by a root pi both cancel. What is remained? H cut k is remained. Right? H cut k, it is remained. This is the value of n square. Okay? N square equal to 1 by a root pi. Now the next question. For a Gaussian wave packet described by function psi of x is equal to a e to the power of minus x square by a square, the expectation value of momentum operator. Again, momentum operator he gave. What we will write? Minus infinity to plus infinity. Psi star. Momentum operator psi dx we will write. Psi star. How much he gave? Right? A e to the power of minus x square by a square. A e to the power of minus x square by a square. In the problem he gave capital S on. Now expectation value of momentum operator. Now here P is there, no momentum operator I h cut dou by dou x into dx. Right? Now next into psi, no sorry not dx, psi dx. So what we will write? Minus infinity. If I is there only it converts into minus I, but here there is no I. A e to the power of minus x square by a square minus I h cut dou by dou x. Again write same psi. A e to the power of minus x square by a square dx. A square dx. Right? Now next so a into a square. Right? Minus infinity to plus infinity. E to the power of these two becomes minus 2x square by a square minus I h cut. Sorry, once again. We have to differentiate this, no? Okay, let us differentiate. If you differentiate, now what we are getting? Okay, minus 2x by a square. X square we differentiated minus 2x. Minus 2x by a square e to the power of minus x square by a square dx. Alright. So now what we did? As usual, this I wrote. A e to the power of minus x square by a square minus I h cut. Differentiation of this value. A. Now first e to the power of minus x square by a square. And again differentiation of x square. Minus 2x square by a square. Right? That only we wrote. Now a into a square. Okay. Now 2 is there. Minus minus becomes plus I h cut by a square integral minus infinity to plus infinity x e to the power of minus 2x square by a square dx. This value is 0. 0 into something is 0. So average value or expectation value of momentum is 0. Okay. Now next, the normalized wave function of the hydrogen atom for 1s state is psi z 100 1 by root pi a naught cube e to the power of minus r by a naught, where a naught equal to h cut square m square b in the Bohr's radius. The expectation value of potential energy. Potential energy formula minus e square by r. So expectation value or average value of potential energy minus infinity to plus infinity, same formula psi star v psi dz. Any I term is in the formula? No. If I is there, it will become minus I for psi star. So now dz or d tau r square dr sin theta d theta d pi. Now the value of integral sin theta d pi theta d pi is 4 pi. Remember standard value. Now integral 0 to infinity 0 to pi 0 to 2 pi e to the power of now psi star e to the power of minus r by a naught into 1 by root pi a naught cube. Okay. Into potential energy minus e square by r into psi, again this e to the power of minus r by a naught 1 by root pi a naught cube. Now into r square dr psi theta d theta d pi. Right? Now here r, 1 r strikes off. Now minus, what you will get? E square I wrote here. Root pi a naught cube, root pi a naught cube, pi a naught cube. Right? The value of this is 4 pi. Now what remains? 0 to infinity. Now minus r by a naught, minus r by a naught, e to the power of minus 2r by a naught. Okay, here 1 r is there into dr. Now this I am writing in this form. Integral 0 to infinity e to the power of minus ax m minus 1. Here r means power 1, no? I am writing as 2 minus 1. Anything changes will come? Nothing. I am writing this in this form. So in place of a, 2 by a naught. In place of m, 2. So factorization m, 2 no, 2 into 1 by a, 2 by a naught whole to the power of, in place of m we are having 2. Now factorization of 2, 1 into 1, sorry. So minus e square by pi a naught cube 4 pi, 1 into 1 by 2 square, a naught square comes into the numerator. A naught cube, a naught square cancels, 1 a naught remains. Minus e square, 1 into 1, 1. 2 square 4, 4 cancels, pi cancels. So a naught in the problem he gave as h cut square by m square. Substituting h cut square, m square comes into the numerator. So what we got? Minus m e to the power of 4 pi h cut square have we got. Okay. So next, let us move for one of the problem. Okay. Using standard definition, find which of the following quantum mechanic operators is Hermitian. 4 options he will give. In that, this option is the Hermitian. Okay. So integral minus infinity plus infinity psi star operator psi dx. Operator he wrote. Integral minus infinity to plus infinity psi star operator I d by dx. With respect to x, let us take no into pi dx. So I am writing out integral minus infinity to plus infinity psi star d by dx pi dx. Right? Minus I. Integral minus infinity to plus infinity psi d by dx pi star. I interchanged it. So I wrote minus here. Psi star pi no. Now what I did? Psi pi star I got. So minus I dx. So now minus I integral minus infinity to plus infinity d by dx psi I am sending inside, I am writing as psi pi star dx. Again I am using UV method, UV dash plus VU dash. Now minus I integral minus infinity to plus infinity psi, first U and this is V, d psi star by dx plus. Now next psi star d psi by dx dx. Right? Minus I minus infinity to plus infinity psi d psi star dx dx. Again minus I am bringing inside. Minus. This minus if I bring inside. Now this becomes minus no. Integral minus infinity to plus infinity psi star d psi by dx dx. Okay. Now here it will be minus I actually this. Okay. Now clear no? Now wave function at infinity to minus infinity, the value of first integral will be equal to 0. Means this is 0. The wave function at infinity to minus infinity, the first integral, this value is 0. So now what is remained? I integral minus infinity to plus infinity. Sorry, no need of minus, no, here plus only. Plus, I will be outside only. Psi star d by dx psi dx. Integral minus infinity to plus infinity. Phi star. I brought here d by dx psi dx. So this is the required one. Now this became 0. Now here I is there. Okay. I integral minus infinity to plus infinity psi star d by dx psi dx. That we wrote I here, I brought I d by dx psi dx. Right? Okay. Now next problem depends upon Pauli matrices. Okay. If n, where n is the unit vector in any direction, commute with sigmas, that is Pauli spin matrices, the value of e to the power of I theta sigma dot n is. We are considering two operators A, B. I am writing it as A dot sigma dot B dot sigma. A means I ax plus j ay plus k az. Sigma means I sigma x plus j sigma y plus k sigma z. Dot. B means I bx plus j by plus k bz. Dot. Sigma means I sigma x plus j sigma y plus k sigma z. Now next multiply this. Ax sigma x dot product plus ay sigma y plus az sigma z. Bx dot bx sigma x, by sigma y, bz sigma z. Dot product, no, I dot I equal to k dot k equal to j dot j equal to 1. Right? Again dot product. So what becomes? Here multiply C. Ax bx sigma x square plus ax, okay, by sigma x sigma y plus next ax. I'm multiplying this with all these three. Ax bz sigma x sigma z plus summation in such a way I did. Now what I am getting, see here, sigma x square, sigma y square, sigma z square. Sigma x square, sigma y square equal to sigma z square equal to 1. Next is sigma x, sigma y equal to minus sigma y, sigma x. In last video we discussed these properties. Right? And now sigma x, sigma z is equal to minus of sigma z, sigma x. Similarly, sigma y, sigma z equal to minus of sigma z, sigma y. Now, first these values are 1, no? 1. 1. So, what is remained here? Ax, bx plus here ay, by plus here az, bz plus. Now, here sigma x, sigma y, if I take common, ax, by minus ay, bx. Y means sigma x, sigma y equal to minus, where I wrote sigma y, sigma x. Sigma y, sigma x. So, ax, by minus ay, bx plus. Similarly, sigma y, sigma z, if I take common, this one. Ay, bz, sigma y, sigma z, sorry. Where is sigma y, sigma z? Here. Ay, bz minus az, by. Right? Plus the other quantity. I got. Now see. Here, this is written, this all term can be written as A dot B plus next, first I am writing this as XY plane, means area is Z. I sigma Z into A cross B Z plus I sigma X. YZ is there, no? So, the perpendicular one is x. Sigma x, A cross x, x plus. Here, zx is there, no? I sigma y. A cross B, y we will write. Now, this or directly we can say all is equal to I sigma dot A cross B. Now, he is asking to find the value of e to the power of I theta sigma dot A. Now, expansion of this 1 plus I theta A sigma dot n by 1 factorial, so on. Okay. Now, minus I square theta square sigma dot n sigma dot n by 2 factorial plus so on. Now first let us find out sigma dot n, sigma dot a, or n dot sigma dot n dot sigma. A equal to b equal to n, we substitute. So n dot n plus I sigma dot in this form, this one what I wrote, in place of a n, in place of b n. So n dot n plus I sigma dot n cross n, right? Now this becomes a dot a no, 1 no, a square 1, that is n dot n 1, I dot I equal to 1 no. Following that n dot n 1 plus I sigma dot n cross n, right? Put it as equation 2, this as equation 3. Now the expansion, 1 plus I theta sigma dot n by 1 factorial minus theta square sigma dot n by 2 factorial plus so. Okay. Now next day, you see 1 plus I theta sigma dot n by 1 factorial minus, this is the formula no. So now if you simplify, 1 minus theta square by 2 factorial plus so on. Okay, first I took 1 minus this one, theta square by 2 factorial, here theta square plus 1 plus, again I wrote this I theta, I common in both, sigma dot n common in both, I wrote theta by 1 factorial here minus theta cube by 3 factorial plus so on. Now we will get this value cos theta plus I sigma dot n, this value sin theta. Okay. The last question of this video. The operator x square px plus px square x square and half x px plus px x whole square differ by the term of order. First, let us write x square px square plus p square x square minus half x px plus px x whole square. Okay. Next, what we will write is half x square px plus x square px square, right? Okay, plus px square x square. This a plus b whole square, a square plus b square plus, okay,